Hi students! Here we are taking another look at a different way of representing concentration. So we've already looked at molarity and percent mass over volume, and now we're going to take a look at percent by mass. It's also called mass percent and weight percent and percent by weight. So sometimes you'll see percent W over W instead of W, sorry, except for already bad here. Sometimes you'll see percent W over W instead of percent M over M, and it's just weight instead of mass. So what we have for percent by mass is we have the mass of the solute divided by the mass of the solution. And with this one, what we need to remember is that the mass of the solution is the mass of the solute plus the mass of the solvent. So usually we're just given the solution as a whole because it's in volume. So with percent M over V, we had the volume of the solution in milliliters, and with molarity, we had the volume of the solution in liters. But now we have to do the mass of the solution and take a look at mass solute and mass solvent. So that's how it's a little bit different. And here are some examples at the bottom. So we can see here that we've got this skin medication right here, and it says that it's a suspension and it's 0.77% by weight or by mass of the active pharmaceutical in that medicine there. Also, you guys can see it on this bug spray here that we've got a mass percent, and it's 25% of one poison and 75% of the other poison. And that's how they're displaying the concentration for us. So let's move right on to some problems so we can see how to work these. So the first problem says that we're going to make a solution by dissolving 7.55 grams of sodium chloride in 52.4 grams of water. And we want to know what the mass percent of our solute is in our solution. So we can go ahead and write the equation for percent by mass just so we can remember what we're doing. And that is the mass of our solute in grams divided by the mass of our solution, also in grams, times 100. Making sure that we remember that the mass of our solution is mass solute plus mass solvent. All right, so then for this equation, what we're going to do is we're going to say we've got 7.55 grams of our NaCl in 7.55 grams plus 52.4 grams, because that's the mass of our solute, and the 52.4 is the mass of our solvent. And when we do solute plus solvent, that is what? That's solution. Okay, and then we're going to multiply that by 100. And we have 3 sig figs all the way around here, and we're going to get for ourselves a 12.6% M over M sodium chloride solution right there. Okie dokie. Number 2 says you make a solution by dissolving 2.45 grams of KCl in 20.6 milliliters of water. What is the percent by mass of KCl in the solution? So if we do percent M over M, we're going to have 2.45 grams of KCl. We don't need to put the KCl there, so we'll just take that off. And we're going to do 2.45 grams plus whatever the mass of our solvent is. Now, our solvent is right here, and that's water. But we don't have it in grams, we have it in milliliters. And that might make us go, oh my goodness, what do I do with that? But if there's anything that you remember from this class, I want it to be that the density of water is what? It's a really easy number. It's 1. So what we can do is we can multiply the volume of water by the density of water, and what we have is we have 1 gram of water for every 1 milliliter of water, and that's the density of water. And that's something we learned in this class. So the calculation on that part is incredibly difficult. We'll have to bust out advanced calculus to do it. And we discover that we have 20.6 grams of water there. Okay, so we've got 20.6 grams, and then we'll multiply that by 100. And what we will get here is we will get 10.6% M over M KCl. And remember, you need to put what kind of concentration that you're using. Are you doing molarity? Are you doing percent M over V? Are you doing percent M over M? Are you doing percent V over V, which we will do in a little bit? And you need to put what the solute is. So the person that is looking at the bottle knows what it is. All right, so we've got one more question in this section. And it says you have a mass percent of sucrose of 10%. And if you use 25 grams of sucrose to make the solution, how much solvent did you use? And remember, if we ask for solvent and it doesn't specify something else, we assume it's water. So again, we can write the equation for mass percent just so we can get used to what it is. Because when we write it out, it gets lodged in our brain. And this is in grams, and this is also in grams. And we want to remember that the mass of the solution is the mass of the solute plus the mass of the solvent. Okay, so what we have, if we just fill in the pieces that we have, is 10% M over M, and we have the mass of the solute. It's 25 grams. And then down here, we're going to do the mass of the solute again, but we don't know what the mass of the solvent is. So we go ahead and put X there, and then we don't want to forget times 100 there. And then we're going to need to use a little bit of magic of algebra here to figure this out. So we want to get X by itself. So we're going to need to move this whole thing, because there's an addition there, so we can't split it up just yet, diagonally across the equal sign up there. And we're going to want to move the 10 down there, and what we'll get is 25 plus X is equal to 25, and I'm just going to move the 100 over here, and we will have the 10 down there. Now, if we are keeping our units, what we'll find is that we have grams here, and we've got grams here, and we've got grams over grams here. Just in case you were wondering where those went, they didn't go anywhere. I was just trying to show you the movement of the numbers without putting all the other stuff in. All right, so we need to subtract 25 from both sides. So subtract 25 from this side and 25 from that side. And what we're going to get is that x is equal to 25 times 100 divided by 10 minus 25, and we will get 225 grams here. Okay, so where did all of the grams go? Well, we had grams here, and we had grams over grams here. So these grams would cancel out, one on the top and one on the bottom. And then if you have something on the bottom of the bottom, it gets a ticket to the top, and we've seen that before. And so you would get a value here that had a unit of grams, and then this one has grams because it was right there. And so you would get a value here minus 25 grams, and that's going to give you 225 grams of water because X is our solvent. And if you wanted to check yourself, what you would do is you'd say, okay, let me erase a little bit up here so I can give us some room. If we wanted to just make sure that our answer makes sense, what we'd say is, okay, let's see if we get a 10%. So percent m over m, and the mass of our solute is 25 grams, and what we'll have on the bottom is 25 grams plus 225 grams, because this is the solute and this is the mass of the solvent, and we just found that down here, times 100. So we will get 25 grams divided by 250 grams times 100, and that is definitely going to give us 10%, and that is m over m because we have grams over grams. And then we would put sucrose if we were labeling a bottle. Okay, so that's going to tell you that it's a mass percent of 10%, and the solvent is sucrose. Whatever you're dissolving in water would be that sugar there. Okay, so that's that part. In the next lecture, we'll go on to percent V over V, and then we'll do some parts per million, and then we'll do some dilutions. Alrighty, see you next time. Bye-bye.